I welcome you all for the topic hybrid drying technologies. So myself, Dr. G. Jeevatram, Associate Professor Head, Department of Technology, Hindustan College of Engineering and Technology, Coimbatore. Today we are going to see about the basics of drying and hybrid drying technologies and its application. So this is the synopsis about today's topic, that is introduction, need for new developments in drying, drying generations, hybrid drying technologies and its multiple innovations, infra drying and its the research findings. Coming to the introduction, so drying is a thermal, physical, and physicochemical process in which the excess of the moisture from a product is removed. If we have a product which is a perishable product which contains a moisture content of 80%, so the drying process which removes the moisture of the product to a safe predetermined limit, for example from 80% to less than 10% or 10 to 15%. So drying is an energy efficient process. So it depends on the technique which we are using, either if we are going for a sun drying, a solar drying, or a hybrid drying technology. So it is an energy intensive process. Drying removes all the microorganisms that is present inside the product that enhances the shelf life of the product. So drying involves heat and mass transfer mechanisms. The heat transfer mechanism, that is the conduction, convection, and radiation, is applied here for the evaporation of the water, and the final product of the end product will be sheets, flakes, films, or powders or granules. So based on our requirement, and if we involve any size reduction operation like hammer mills or burr mills or ball mills, the product can be converted into a powder. Or if we need a flakes, we can go for a certain kind of operations. And drying that helps to reduce the post-harvest losses, stabilize the prices, and it also reduces the capital investment in transportation, facilitates long storage, and extend the farm beyond the season. The mechanism behind the drying is the movement of moisture from the interior towards to the surface and surface to the atmosphere. So it involves the constant rate of drying, first falling rate, second falling rate, and finally you attain the equilibrium moisture content. So this is the drying process which takes place. And why we need for a new developments in the drying? So normally the farmers, they have chosen the sun drying and solar drying. And sun drying, it is a weather dependent, and sometimes the weather may be, for the temperature may be higher, and sometimes and the temperature may be lower, and it is also depends on the temperature and relative humidity that is present in the atmosphere. And solar radiation, we can collect the solar sun rays, and we can and give inside a chamber with the help of the air. The air gets heated, and the heated air will be passed over the food product, so the drying will be takes place. So it is a longer process where when the product is exposed to a longer temperature, the quality of the product gets affected. And in conventional drying process, it may be suitable for some of the products, but for not for all. So it gives an inferior quality products and a less poor drying rate and higher drying times. So this is the purpose that we need for an alternative drying technologies. That is a novel drying technologies. The main aim is to improve the quality, or at least we have to retain the quality of the product, improve the drying rate, and also we have a lesser drying time. The exposure of the product towards to the should be very lesser. So coming towards to the development requirement is, it is operational capacity, process control, time requirements, cost economics, product quality, safety, and environmental aspects. So the novel drying technologies which gives an intelligent combination, that is a combination of one or two dryers, and conventional technologies, a combination of the non-thermal technologies with the conventional technologies, and the consumer requirement. So the need, before going for a designing of a new dryer, you must keep these things in the mind. That is the temperature and pressure level in the dryer, the type of the food material to be dried, the heating medium required for drying, and method of moving the moist material. That is either by using a conduction mode or a convection mode or a radiation mode or a combination of radiation and convection, etc. And the mechanical aid in circulation of air, either the uniform circulation or volumetric heating which is achieved inside the product, and ways in which material is supported, and nature of the wet material, etc. These things should be keep in mind before we going for a design of a dryer. And also the type of food material is very important, and the energy consumption of the dryer and the efficiency of the dryer is very important here. So coming towards to the generations. So we have four kind of generations. The first generation is the only they are using hot air as a medium, and the example is tray dryer, kiln dryer, truck dryer, tray dryer, tunnel, and rotary flow conveyors. This is the example for the hot air. So the first generation that basically involves hot air, that is a convection mode as a heat transfer medium. And coming towards to the second generation, they have used the conduction and convection. Here the spray dryer, which they have used for converting the powders, and drum dryers that also used for the conversion of the powders. So drum dryer is a kind of a conduction medium, and spray dryer is a type of a convection transfer method. And coming towards to the third generation, that is a freeze dehydration and osmotic dehydration. So freeze dehydration and osmotic dehydration, which also gives quality products, the retention of quality is higher, but in terms of the capital cost, which is higher compared towards to the other type of dryers. And fourth generation, that involves the non-thermal, that is using electromagnetic radiation drying techniques. That is, the example is infrared, microwave, fluidized bed, refractance window, the heat pump drying, radio frequency, and other kind of hybrid drying technologies. So the hybrid drying technologies, which also improve the recover the quality of the product, that is the quality retention, as well as the lesser drying time and improved drying rates, which can be obtained in the fourth generation technology, that is the infrared, microwave, fluidized bed, refractance window, and other hybrid drying technologies. The hybrid drying involves the combination of infrared with microwave, or combination of infrared with hot air, or combination of infrared with vacuum, or microwave with vacuum, microwave with refractance window, etc. So nowadays, these hybrid drain technologies have wide popularity due to its quality retention. And the concept is to satisfy the consumer needs and to produce a product with suitable moisture content. So hybridization is, that is a combination of two systems or two or more drying systems. That is a hybridization or hybrid drying technologies we coined here. And the objective is to produce improved quality food material, reducing the drying time and improve rate of drying. It also enhances the shelf life, also the increases the quality of the product, also it gives the value for the product. So this is a hybrid drying technologies, that is a combined drying technology, multi-stage drying technology, and multi-process drying. So combined drying means, as I told, infrared combined with the heat pump drying or convective or vacuum, and multi-stages, which the 2-stage, 3-stage, and 4-stage kind of multiple stage drying techniques, and multiple process, either it's a drying followed by a filtration drying followed by a cooling, etc. And infrared drying involves by using the electromagnetic radiation, the electromagnetic waves that impinges the radiation impinges the product. Inside the product we have a moisture content which is acting as a polar molecules. The polar molecules absorbs the radiation and it will give the electronegativity will be taking place, that is the transfer of electrons among the water molecules will be taking place, the positive charge and negative charge, where the ionization induces here. And the molecular friction, because of the movement of the molecules, a molecular friction will be created. That molecular friction will be converted into a thermal energy. So that thermal energy, it will be giving a drying effect. That is the movement of moisture from the inside towards to the outer atmosphere, surface and outer atmosphere. So infrared drying is an electromagnetic radiation drying, and they have a specified wavelengths. So the thin layers that is suitable for the far infrared radiation, and thicker layers which will be suitable for near infrared radiation. So based on the wavelengths and based on the thickness of the material, it may be varying. So it gives benefits like more energy efficiency, enhanced quality, volumetric heating, uniform heating distribution, and reduction in the airflow requirement, etc. And this is the infrared radiation that is combined with convective air. This is an example here. So here the infrared radiation impinges radiation on the food material, where the water is one of the polar molecule which is acting as a heating medium. And here we are passing the hot air parallelly towards the infrared radiation, where the hot air also gives a uniform drying. Here the drying efficiency increases, the lesser drying time, the quality retention is higher, and a volumetric heating will be taking place. And these are the recent researches on hybrid drying that is taking place. So hybrid drying it gains more popularity, and it is nowadays it is usually here. And this is the publications with respect to hybrid drying techniques which I have carried out here, and my area of research work also with respect to hybrid drying techniques. So thank you for listening my video lecture, and I will be joining shortly with another topics. Thank you.